Hello class, this is Ms. Chakoi. So this is you don't have this worksheet, so you just need to do it off the video. But I want you to try this problem below on your own first, so you can pause the video, and then come back, watch, and correct it in pen. So give yourself about 5 to 10 minutes, and I would probably err on the side of 10 minutes to give yourself enough time to really work through it. If you get completely stumped, then you can come back, watch, and then finish it out in pen. Because I want us to be able to see where you got mixed up or where you need help. So please try it on your own in pencil, watch and correct in a colored pen. So now that you've tried solving it on your own, first step is draw a picture. So we have a bullet is fired from a gun that's held parallel, so we know that our line is going to be parallel. And it has the initial velocity of 2.2 meters per second. And notice, since this is horizontal, this is only in the x direction, which is important to note. And we know that this gun barrel is 5.5 meters high. So now we want to do any triangles. You'll notice there are no triangles because there are no angles. Yay! So you don't have to break it up or do any sine or cosine. After that, you need to make your x and y chart. So you need your x naught, your x, your v naught, your v, your a, and then t is the only thing. So x naught is 0, our final x, we don't know. It's 2.2, and our acceleration is 0. Since our acceleration is 0, these end up being exactly the same. And then we do the y direction. Its initial position in the y direction is quite tall, so we start off at 5.5 meters. Final position, it falls, so it goes down to 0 meters. It hits the ground, as things do when you drop them. Initial velocity, it's the nice one, because since all of this is horizontal, none of it is vertical, which means we start it from rest. The final velocity, we don't know yet, but we know that since it's falling, acceleration is negative 10 meters per second due to gravity. So first thing we need to do is find time. We're going to solve for time using our y. Always use y because that determines whether or not it falls. You're going to be using the first equation for this because with that equation we notice some really good things. Since our initial velocity is 0, that's our final velocity, our final position is 0. So then we get to plug in and it becomes a lot nicer. Alright, then you can rewrite this. This is 0 equals x naught plus 1/2 a t squared. We know that in this direction, and actually I'm going to go back and I'm going to solve for our t squared first. So we can move this x naught over, so we get negative x naught equals 1/2 a t squared. And then remember, if we want to get rid of something, we divide by it, so a should be on the bottom. And since this 2 is already on the bottom, we're actually going to put it on top. And anything I do to one side, I must also do to the other. So I'm going to pause and simplify this whole mess to make it easier. So for you, just keep writing below. For me, I need some more room. Alright, so that's simplified out. And the only thing left to do to our t is we must square root it. Alright, so that negative in there, and since remember our acceleration is negative, that will end up canceling out to be positive, so don't worry. So now all you have left to do is plug in your numbers. So we have 2 over negative 10 is our acceleration, times our initial height, which is 5.5. Plug that in, equals 1.1 and then you're going to square root that 1.1, which will give you, for time, equals 1.05 seconds. You could also have rounded that to 1 second. So for A, the answer is 1 second. So now we're going to do part B. So we can fill in our time as 1 second. So now part B is asking how far horizontally. So we care only about the x direction, which means we're going to use the first equation again to solve it. Our A is 0, which is going to be very nice for us. And actually a lot of our things are going to cancel out because they are simply 0. So this is 0. Our initial position is 0. So the only thing that matters is our initial velocity. And you're going to find this true about all range equations, is that the range, or the horizontal distance, only matters in the v-naught. So the final distance, we're not sure, but we do know that our initial velocity is 2.2. We know that it gets to go for 1 second. So 1 times 2.2 means it goes for 2.2 meters. And if you want to see the cancel, it's meters per second. Our seconds cancel. We are left with meters. Hopefully this video is helpful. Remember, we do have a test coming up on Friday on two-dimensional kinematics.